Hi all, welcome back. For anatomy and physiology, we're going to talk about connective tissue now. Um, so we left off, we were talking about epithelial tissue, and so now we're going to talk about another tissue type called connective tissue. And you'll see that connective tissue is kind of like the catch-all of tissue types. If it's not epithelium, it's not muscle, it's not nerve, then it's pretty much connective tissue. So everything else kind of falls into this category, and you'll see that there are some similarities and then some major differences between the different types of connective tissue. So first of all, it's very abundant, um, widely distributed, and often the way it differs from the other connective tissues are the cells are have more space between them, typically. Okay, it depends on the connective tissue, but there's more space. So they occupy less space, and there's more fibers and other things that are associated with um, the tissue type. So most cells are not in direct contact with each other. Now, of course, there are some types of connective tissue, like bone, where the cells are in direct contact with each other. But majority of connective tissue, the cells are not in direct contact. And again, this makes kind of that catch-all of everything. Um, it's super important, connective tissue is, for all the other tissue types, because connective tissue, having that space, having a area at which blood vessels can penetrate, really allows for connective tissue to kind of be that connector, hence the word connective, okay, between different tissue types, between muscle and epithelial, between nervous and muscle tissue. Okay, and so some connective tissue has association with blood, and others do not, and we'll cover each one of these as we progress. So let's first look at the functions of connective tissue. One of the main functions is binding of organs. So connecting one bone to another, connecting muscles to bones, connecting skin to muscle, holding the organs in the body in place. There's lots of ways at which they bind to organs. Okay? Not only the binding of organs, but also supporting it. So support it by creating a framework, or protect it by creating some kind of cushion or protective barrier from the external environment, or from blunt forces or anything like that. Okay? Adipose tissue is a very good example of cushioning for things like organs and other regions of the body that you don't want damage. Even cushioning between epithelial tissue and muscle tissue, you'll often have a fairly thick layer of adipose tissue, that connective tissue that prevents the damage to muscle tissue. Immune protection, okay, we'll cover the immune system in much greater detail, but the immune protection, again, connective tissue, it will create a barrier between even internal environments and sensitive tissues or delicate organs. Okay? And so it just provides another layer of support. And in fact, one of the main connective tissues that we will talk about is blood. And part of that blood system is white blood cells, and their job is immune protection. Okay, let's look at some more movement, storage. Okay, so movement, of course, have to have a framework. So muscle tissue is a different type of tissue. We'll talk about it later. Okay, but connective tissue is the tissue that connects muscle to the bone, or provides a scaffolding for movement, some kind of lever system. Storage, again, we'll talk about adipose tissue. Energy storage is huge, and very important job of fat tissue. Heat production, okay, not just the production of heat, but the maintenance of heat, okay? So trying to maintain that homeostasis that we talked about before. So brown fat can generate heat, but white fat is a great insulator, so it maintains the heat that is being generated. Transport blood, or transport blood itself is very good at transporting gases. Okay, and then there's transportation of waste, and so those wastes could be gases, okay, or the waste could be products of metabolism, like ammonia, that might be developing after the breaking down of, say, protein and things like that. We'll come back and we'll look a little bit deeper into some of these transports. Okay, so what gives connective tissue its structure? Let's talk about the cells. Okay, so the first cell type that we're going to talk about is fibroblasts. Okay, so they produce fibers, and you can think of fibers as strands of proteins. Okay, and these strands of proteins, they can be different shapes, different sizes. We'll talk about some of them, but those strands of protein really provide a matrix or some type of scaffolding or structure, so the material has some kind of resistance to movement. Okay? Some materials are way more flexible than others, some connective tissues. Some connective tissues have very little flexibility, and a lot of that has to do with the fibroblast and what type of fiber is being laid down and how much of it. Okay? Macrophages. So when we get into that immune function, okay, the macrophages are really important for immune function. Okay? They phagocytize, they consume things. Okay? We talked about this before. One way for a material to get into the cell is through phagocytosis. Macrophages are really good at doing so. They'll eat it, so they bring it in, break it up, and then present material to other cells. And so they're making antigens. They're presenting them to other cells so the other cells can react to those antigens by producing antibodies. Okay? So leukocytes or white blood cells, okay, they're part of that immune defense. Again, we'll dive into these a lot more in future lectures, but just part of that cell structure. Okay, so you can expect to find fibroblasts, macrophages, leukocytes, plasma cells, okay, mast cells. They're important for inhibiting clotting, but also dilating blood vessels. Okay, adipocytes. Okay, we already kind of talked about this. Adipocyte or fat cells are important for energy storage and cushioning or protection of organs and other situations. Okay. So let's dive in a little bit more into the fibers. Okay. So there are a few different types of fibers. There's collagenous fiber, or fibers that are made out of collagen. Okay. Collagen is a protein structure. It's triple helix, okay, and so there's amino acids chained together, and typically it's 3 strands that kind of wrap around each other to form a collagen structure. Okay? It has flexibility, but it's not quite as flexible as some of the other material. It's more, it has good rebound properties, but it also provides support, and it's harder to tear than some of the other fibers. Okay, so pretty good support. Often has kind of a white uh, color to it when you look at it, maybe examining like cadavers or things like that. Even not even cadavers, even live tissue will kind of have a white sheen to it, and often it's called white fibers because of that. Reticular fibers, okay, these are a little bit different. Collagen fibers um, tend to run linear in strands or waves. Okay, reticular fibers tend to be more like a net. Okay, so they go lots of different ways, and they're coated with glycoproteins, um, often making up a lot of what we call the basement membranes. And so we'll look at the importance of this and how that works um, later. And then kind of the last type of fiber that we're going to discuss are elastic fibers. Elastic fibers are, just as the name suggests, they're like an elastic band. Okay, very stretchy. Okay, they snap back. However, they're not as rigid as the collagen fibers, so they tend to tear easier. They tend to be damaged easier, but they have more flexibility. So if you think of kind of like your ears, how you can kind of fold your ears around and move them around, things like that, that's because there's a lot of elastic fiber in that region, and that's made of a protein called elastin versus collagen. Okay, so just an example. So there's those white fibers. That's kind of where they get their name, white fibers. But those collagen fibers, a couple examples of that is tendons. Tendons connect muscle to bone. Okay, and then ligaments connect bone to bone. Um, and so if you're a fan of sports, one of the main injuries in college sports, the NFL, the NBA, I mean, any place where individuals are making lots of cuts and quick movements side to side, um, you'll see tears of things like the ACL, okay, or that ligament that holds those bones together. MCL tears, okay, that inner ligament, and occasionally LCL tears, okay. And we'll come back, we'll look at some examples of this when we do some more case study stuff as we progress. But just just keep that in mind. Tendons connect muscle to bone, ligaments connect bone to bone. All right. There's also two kind of broader categories. So not just the fiber type, okay, but how is the fibers arranged, okay? And those are called loose connective tissues, okay, or dense connective tissues. Okay? And you can have different types within that. Okay, so you can have auroliar and reticular for loose connective tissue. And this really, loose just means that there's a lot more space. That space can be occupied by gases, that space can be occupied by water protein mix, that space can be occupied by blood vessels, but there's just a lot more space um, in that loose connective tissue. Dense connective tissue typically means those fibers are stacked on top of each other pretty tightly. Okay, if it's regular, it means they're all in the same plane, moving in the same direction. That could be a wave, it could be linear. Okay, if they're irregular, still dense, but they tend to kind of move, might be fold over on top of each other, things like that. We'll look at some examples of all of these here next. Okay, so auroliar tissue, again, fibers. It can have both. Typically, they do. Actually, most of the regions that we'll talk about will have both collagen fibers and elastic fibers. Um, they just may have more of one type, which makes it more rigid or more flexible, kind of things like that. So, in the case of auroliar tissue, hey, you'll often have a lot more space. You have a lot more uh, open areas where maybe you have ground substance, which is typically kind of proteins, maybe some sugars that are kind of in solution, mixed with water. And so the fibers themselves are loosely organized, and there's lots of blood vessels that are running through the tissue. Okay? So often this will be associated with regions where you need to get a lot of oxygen, nutrients passing. Okay, so right underneath the epithelial cells. We talked about the epithelium before. There are no blood vessels in the epithelium. So right underneath that, this kind of tissue type you would find because it's supporting the epithelial cells. It's providing the epithelial cells the oxygen and nutrients that they need in order to divide and grow. Okay, reticular tissue, again, still fibers, but these fibers are kind of more of a net or kind of in a pattern, an irregular pattern, still have lots of space. Okay, those space typically are occupied by blood cells, different types of blood cells, red blood cells, white blood cells. Okay, you see a lot of reticular tissue associated with things that are associated with the circulatory system. So bone marrow, the spleen, lymph nodes, which might be associated with white blood cell production and storage and things like that. So often where there are lots of blood cells either being generated or accumulated, you'll often have reticular fibers. Uh, that dense regular connective tissue, so here's a good example of that. Okay, it looks like long sheets. Okay, sometimes kind of in this wavy pattern like this is the Achilles tendon. Okay, gonna have still collagen fibers, and the majority of it will be collagen fibers. It depends on the region. You may have some elastic fibers in mixed in. Okay, but lots of collagen fibers. In between, you'd have ground substance. Remember, ground substance, we talked about this before. It's really just kind of a protein, sugar, water mix that just provides kind of a liquid platform in between fibers. Okay? And it's important for both tendons and ligaments. Okay, so dense regular connective tissue builds both tendons and ligaments. So regardless of whether you're attaching it from muscle to bone or bone to bone, dense regular connective tissue is normally kind of the tissue type or that category. Dense irregular connective tissue, okay, still dense, still you're going to have that ground substance, you're going to have that space in between, except for now the fibers, instead of running kind of all in one direction, they tend to fold back on each other. They have a very different shape to them. And one of the main reasons for this is that dense irregular connective tissue allows for forces to basically come at any direction. Okay, so right underneath your skin, top layer of your skin, the epidermis, okay, you would see dense irregular connective tissue. Okay, and that really allows for a force to come at this angle, down, okay, backwards, and it really any direction. This can kind of absorb that force and protect the muscle fibers that are further down. Okay? Versus something like a regular connective tissue, okay, like your Achilles tendons and things like that, okay, they're in a linear form, so a force going too much from one side could actually cause a tear and cause damage. These are much better at absorbing unpredictable stresses. Okay, but again, it's not as rigid as the dense regular connective tissue, so you can have movement of this material. Okay? All depends on what it's made out of. All right. Let's talk about that adipose tissue. So again, important for providing energy for the body. Okay, adipose tissue or fat is just super important for providing a way to store energy. But apart from that, it's very important for protection. Okay, and you'll see adipocytes in lots of regions. Okay, often associated with blood capillaries because again, these are fat storage or energy storage material. And so you can get that energy or components of that fat being broken down and then passed on to cells so the energy can be utilized. So primarily, it's energy reserve. Right? And we think of it as being stored as what we call triglycerides. Triglyceride means that it has 3 fatty acid tails. Right? Monoglyceride would have 1, diglyceride would have 2. This is kind of the typical setup of a type of fat storage. Okay, and all of them can occur. Okay, but in humans, the most stable kind of fat is a triglyceride, and so that's what we see a lot of. Okay, again, these are recycled, can be hydrolyzed and then released into the blood, and then those hydrolyzed fat, which just means it's broken down into smaller parts, typically fatty acid chains with carbon hydrogen bonds being broken later on, so the energy can be utilized for things like the electron transport system and generate ATP. Okay. All right, 2 types of adipose tissue. White, which sometimes it's called yellow because when it's observed on a dissection or even a cadaver or um, through surgery, it tends to have a yellow tinge to it. And then brown fat. Okay. White adipose tissue, sometimes called WAT, um, is the most abundant, especially in adults. And its main job is energy storage. Okay, but opposed to that, or in addition to that, um, it also provides that protection for certain organs, especially sensitive organs that can be damaged easily from forces outside or inside the body. It tends to build in certain regions where you may need protection against blunt forces. So, like the stomach region underneath the ribs, that region tends to build up a lot of white adipose tissue. There's no protection from the ribs for the organs in that region, and you tend to build a lot of protection in that region, so it's stored there. Stored also in the breast, hips, buttocks, okay? And a lot of this is for energy reserves, okay? In case of pregnancy or feeding offspring, okay, you'll want a lot of energy reserves in those regions to maintain that offspring. And so that's why it's deposited there. Brown fat. Brown fat is a little bit different because it has a lot of mitochondria. Okay, and so it gets its color from more blood vessels, more mitochondria, mitochondrial enzymes. Okay, tends to reflect a brown color. It's a lot like if you know, Thanksgiving. If you're a white meat person, then the breast muscle of a turkey, turkeys don't fly, really. They they can fly, especially wild turkeys, but domesticated turkeys, they really don't fly. So they don't use that muscle like they use their legs. And so the breast muscle is white because there's hardly any mitochondria and there's very little energy being processed in those regions. Okay? And the leg muscles and the wing muscles are brown meat because It's got mitochondria and mitochondrial enzymes associated with it. Fat's no different. Same kind of process with fat. Okay, white fat, very little mitochondria associated with it. Brown fat, lots of mitochondria associated with it. Okay, it's just a couple examples. Here's white fat, brown fat. Under a microscope, kind of difficult to see. If you went to an electron microscope, you would see a lot more mitochondria associated with the brown fat, hardly any associated with the white fat. But you can still see that there's difference. These fat cells tend to be open and not have much material inside. There's clearly some kind of scaffolding matrix inside a lot of these cells, indicating that it's brown fat. All right, cartilage. So cartilage tends to be a stiff connective tissue. Um, Depending on the region, will depend on what type of fibers make up that cartilage. So you can have cartilage that is very rigid, okay, which is going to have a lot more collagen deposited. You can have cartilage that is associated with a lot more flexibility, and you're going to have a lot more elastin. Okay, but cartilage in itself is generated from chondroblasts. These are cartilage cells, and that's what's going to make the matrix. Chondrocytes are cartilage cells that have been trapped in leucana or the cavities. Okay, they're important because these cavities create space and well, allow for kind of uh, the material, the cartilage itself, to be more flexible. Um, and not as rigid as, say, bone. It's not ossified, so there's a lot more flexibility around it. Okay? And if you ever get a chance to look at cartilage, it'll look like it has a lot of air bubbles. That's the lacunae cavities is going on. The perichondrium is a sheath of dense, irregular connective tissue that covers, okay, the material. And we'll talk about the different types of cartilage, the elastic cartilage, the hyaline cartilage here in a second. Okay. The importance with the perichondrium, okay, is that it contains extra chondroblasts. Okay, so it contains a reserve. So if occurs, okay, it can deposit chondroblasts. Chondroblasts can continue to build a matrix. Hopefully, in many cases, rebuild a matrix if it's been damaged and things like that, which we'll talk a little bit about when we get to kind of talking about the different types of cartilage. Okay, one of the key components is it's avascular, so there's no blood capillaries. So all the nutrients, all the oxygen, carbon dioxide, waste, and everything like that is diffused across other layers, across blood vessels that are nearby, okay, into the cartilage and out of the cartilage. So if you damage cartilage, the healing is slow. Okay. It's also rich in what we call GAGs, and GAGs are glycosaminoglycans. These are really, really important in cell-to-cell communication, but it's also important to build kind of that part of that matrix, and so they contain that collagen fiber, okay, which really adds to the rigidity or lessens the rigidity. However much you have in the region will determine kind of how rigid that cartilage is. Okay, so three main types: the hyaline cartilage, fibrocartilage, and elastic cartilage. Okay, so we'll cover them real quick. So a hyaline cartilage, sometimes called hyaline cartilage, okay, it's super abundant. Okay, the most abundant kind of cartilage that we have in our body, and it's well known. It's easy to tell because it tends to be like a glassy appearance. So it's nearly see-through. Um, it has really, really fine collagen fibers, making it not super rigid. And so it's has some flexibility to it, but it also maintains its shape. Okay, and so your tracheal rings are a good example of this. It's a major part of the fetal skeleton, especially juvenile long bones. Okay, so if you're not familiar, cartilage changes into bone with the addition of a um, calcium carbonate derivative called epoxyapatite. Okay, and so that material, when it's added to cartilage, it will ossify and it'll turn the cartilage into bone, or the process will begin to kind of turn that material into bone. It's important for the juvenile long bones that they're made out of cartilage. They're much more flexible. Often people will say, oh, kids are way more flexible. They rebound, they bounce back. Okay. Part of that is because their bones are a little more flexible because there's a lot more cartilage associated with them. As you age, that cartilage ossifies and becomes bone and then takes a more rigid structure. Okay. Less flexibility. Elastic cartilage, great example of this is the ear. Okay, and so again, most of the fibers that are associated with it are the elastic fibers, not collagen fibers. So it has a little, well, quite a bit more flexibility. However, that being said, it can be damaged and have some kind of unique damages. So the perichondrium is the covering that's going to cover this material. And what can happen, and many of you have probably seen this in individuals that like you've seen a wrestler or an MMA individual or a boxer that's been hit in the ear and they have what we call cauliflower ear. Okay, what happens is the blood vessels in between the pericardium and the elastic fibers, okay, they burst. Okay, and the pericardium tends to tear also and stretch. And so you get a lot of blood vessels that have ruptured, hematomas in that region, so the blood's leaking out in that region, and it creates these little pockets. Okay, and that'll create the bulb, or that'll create the swelling. When that swelling goes down, though, and this is kind of an interesting piece, these elastic fibers and the chondrocytes and things that are going to try to repair that region tend to repair it not in the same shape. They repair it kind of bumpy and lumpy, and that's what gives that ear that cauliflower look to it. But nonetheless, that elastic cartilage is really flexible and important for that. Okay, and then fibrocartilage. Again, heavy amount of collagen fibers in this one, and really, really important for the discs in your back, for intervertebral discs, or the disc between the vertebral columns. Okay, a lot more rigidity to it, still flexible, and that flexibility allows us to absorb shocks or shock. So the fact that, especially us being bipedal, the fact that this is being pressed down constantly by gravity, is it's a very useful evolution of what was once the notochord. Okay, and we're not going to dive into too much comparative anatomy, but in other organisms, these discs is known as the notochord, and still made of chondrocytes and collagen fibers, but now our discs, our notochord is in between, and make our intervertebral discs. Other things where you might have a lot of shock, where you need to absorb shock, like the meniscus disc and other things, also have kind of fibrocartilage. We'll talk about that. But remember, cartilage doesn't have blood vessels, so if you damage it, it takes a very long time to heal because you got to have this absorption of nutrients from outside that region. Okay? And so if you damage it in the center of, a disc or tear in a meniscus, okay, it can take a very long time to heal that material. All right, bone. Okay, bone is cartilage that has been ossified, and so it's it's super important, obviously. I mean, I don't have to tell you guys that, but there are two real types of bone. There's what we call spongy bone, which, like the name suggests, it's a little more flexible. At least flexible in the sense that it's not really tightly packed. You actually have blood vessels that run through it, and there's a distinction between where the cells are at. And many of you guys have probably seen this before at the heads of long bones or the middle of the things like the sternum. You've probably seen it, the bone looks like it's got a bunch of holes in it. It's aerated. Okay, and then the other type is compact, dense bone. Okay, again, this is just dense, more dense. The cells are next to each other. There's really no visible space. There is space, okay, but no visible space, especially with the naked eye. And this is the external part of all the bones. Okay, so the internal part in certain regions will be spongy bone, and then the external coating is compact, dense bone. Okay, so some things about the compact bone, um, and is they're really arranged in what we call ossetones. So these are like regions of the bone that kind of have a canal, an ossetonic canal or a central canal that runs through the middle. That's where the nerves and the blood vessels run that feed and react to stimuli in that region. Okay? Around it are rings, right, which we call lamellae or concentric lamellae, okay, and that surrounds the canal. And so they're built kind of in layers, rings, okay. Really important for lots of other organisms. If you're an individual that looks at growth rate, aging, that kind of stuff, lots of organisms that are indeterminate growers, things like amphibians, reptiles, fish, etc. These bones, that layering of rings can be used to age the organism. Not so much in humans. We'll talk about how you can age humans later. Um, Really has to do with the spongy bone versus the compact bone, and the differences there is one of the good ways to age humans. But ossitone, that's what we call the central canal where the blood vessels are running. Osteocytes is what we call a bone cell. So cytes, anytime you see cytes, it's referring to cells, and then typically the beginning of that word will indicate what type of tissue or what type of cell, or have something to do with the region maybe, but osteocytes or bone cells. And the canal luculae, that is going to be these kind of radiating lines that allow the connection between ostones. So you have ostones that are next to each other. I'll show you a picture of it, okay, in a second. The peristemium, most of you probably actually seen this. Your teeth have probably hit this. Okay, if you're eating something like a chicken bone, you eat all the chicken off of it, there's a little cover that covers the outside of the bone, the whole bone, peristemium. And if you let that bone dry down, like if you've dried down a wishbone or whatever, you can actually peel that thin connective tissue layer off of it. Okay, so here's just an example cross section of a bone. You can see the central canal, you can see the entire ostium. Okay, that's that whole region. But you can see these canal lucii that connect between the two, and so that really allows for transfer of material, but also kind of cell-to-cell communication. Not like, hey, how you're doing kind of communication, but more like you need to grow more communication, like stimulation to grow faster or slow down growth, those kind of things. That's kind of communication that would be happening typically in these regions. All right, and the last one I want to talk about is blood. So blood, again, blood is just the fluid that is traveling through blood vessels, but it's the fluid that typically is delivering things like nutrients or at least delivering oxygen and removing waste like carbon dioxide. Okay, so blood will consist of lots of different elements. Okay? When we're talking about humans, these are the main ones. Okay? Erythrocytes, or the red blood cells, leukocytes, the white blood cells. These are defenders against infection, disease, and parasites. Okay? And platelets. These help form ability to clot. We'll come back talk about blood because we're going to talk about the immune system, and this is a major component of it. But when we look at a blood smear, okay, in the case of mammals, humans included, okay, our red blood cells don't have any nuclei, so you can see all these little pink dots. They are all red blood cells. White blood cells do have nuclei. You can see them here, and so there's different types. Some are multi-lobed. Some are just have a large nuclei. There's lots of different types, and we'll come back and talk about the different types of white blood cells. And then you have platelets. Platelets are like little discs that tend to clump together, and so when you have a wound or whatnot, that's what's going to clog that wound and stop the leakage of blood out. Okay, next time we are going to talk about muscles and nerves.